We continue. So, can expert system make mistakes? You have to bear in mind, even a brilliant expert is only a human and thus can make mistakes. So, then we should suggest that an expert system built to perform at the human expert level also should be allowed to make mistakes. But we still trust experts. Even we recognize that their judgment are sometimes wrong. Sometimes even the expert also they are making mistake. I mean expert human. So likewise, at least most cases we can rely on the solution provided by the expert system. It means that still even though we make mistake, at the end still we still trust the expert. But mistakes are possible and we should be aware of this. So if we use the expert system, consider that the expert system will make mistake and we should be aware that the expert system are making mistakes. In expert system, knowledge is separated from its processing. It is different between knowledge and the processing. Where the knowledge base and inference engine are split up. See, it is based on inference engine. A conventional program, it is mixed between the knowledge and the control structure in order to process the message, in order to process the knowledge. And this mixing actually leads to difficulties in understanding and reviewing the program code. So any change to the code affect both of the knowledge and also its processing. So in the conventional method, if you change the code, mean actually you are changing both of it, knowledge and processing. Whereby if you use, if you are developing the expert system, you are doing it separately. You can update the knowledge without any affect the inference engine or the processing. So when an expert system shell is used, the knowledge engineer or an expert simply enter a rules in the knowledge base. You just you update the knowledge, you add the knowledge. Where each new rule adds some new knowledge and makes the expert system more smarter. This statement in the beginning of the development of the expert system, yes, but you have to be aware that sometimes when you attempt to add more and more rules, it will come to the situation where it is redundant, and once it's redundant, it can make a simple mistake. But nevertheless, if you add a new rule, is that you add a new knowledge to the system. Okay, this is the comparison between the expert system, human expert, and conventional program. Here we have three columns. The first one is the expert system. The second one is the first one is the expert, human expert system, and conventional programs. Where in expert system, it use the human expert use knowledge in form of rules of thumb, and heuristic to solve problem in a narrow domain. Means that it is based on the experience he has acquired it previously. Wherein expert system process knowledge expressed in the form of rules and symbolic reasoning to solve problem in a narrow domain. While in the conventional program process data and use algorithm, a series of well-defined operations to solve general numerical problems. In human expert, human brain knowledge exists in a compiled form. Okay, until today also, uh, I mean, we are trying to mimic, try to duplicate the human brain, but until now, I think we cannot. It's not possible as it is God created, so it's impossible to duplicate the same. In the expert system, provide a clear separation of knowledge and its processing, while in the conventional program, you don't have separate knowledge from the control structure to process this knowledge. Human expert capable of explaining a line of reasoning and providing it in details. Okay, once you get into conclusion, it has the ability to give the explanation, and this explanation will be in detail. While in the expert system, it need to trace the rule that been fired during a problem solving session, and then explain how a particular conclusion was reached and why specific data were needed. Okay, while in the conventional problem, it cannot give any explanation since it don't have the capability to give the reason behind what the conclusion has been made. Okay. Expert, human expert also use exact reasoning, okay, and can deal with incomplete, uncertain, and fuzzy information. If you didn't provide the complete data, the complete fact, or even the fact that we given is fuzzy, it can deal with it. It can use it. Same as expert system. Expert system also can deal with incomplete, uncertain, and fuzzy data, but not in the conventional program. Okay, only work only if you present a data. Human expert can make mistake when information is incomplete or fuzzy, at least to a certain degree of conclusion it can be. Where in expert system also it can make mistake where the data is incomplete or fuzzy. But in the conventional program, no solution can be made if you don't provide any data. In human expert, in order to increase the quality of problem solving, it goes through a learning and practical training. Okay, this process actually is really slow, it is inefficient and expensive. Even though the expert system still required from expert domain, but in order to upgrade, in order to gain a new knowledge, it's quite simple and easy to accomplish. To enhance the quality of our sermon by the conventional program, which affect both and knowledge and processing, so it makes it difficult to make changes compared to both human expert and expert. system. Now we look, there are two structure in outline the rule inside the knowledge base of the expert system. Okay, we have a forward chaining and also a backward chaining. So what is forward and what is backward? We are going to discuss in detail. Okay, in the rule based expert system, the domain knowledge is represented by a set of if-then production rules. And data is represented by a set of facts about the current situation. Normally, you have already the data where the fact is already available, but certain fact are going to be available once you complete certain rules. When the certain rules expired, then you gain a new facts. So in the inference engine, compare each rule stored in the knowledge base with facts contained in the database. When the if condition part of the rule match a fact, then the rule is considered fired. Where if the rule is fired, then its then action is executed. Sometimes this then action that executed create a new fact where it will add later on in the database. So the matching of the rule if part to the fact produced by inference chain. The inference chain indicate how an expert apply the rules to reach a conclusion. Okay. So it is a processing part of the expert system is the inference engine chain. Okay, if you look here in the block diagram, we have a knowledge base and a database separately, where you put a rule in the knowledge base. There are a rule in the knowledge base where the rule require a database in order to be fired or to be executed. Okay. There are also some facts in the database available, and also fact will be accumulated, will be added while the rule is being fired. Some of the fact in the database is acquired through fire of the knowledge base. Sorry, rule in the knowledge base. I'm so sorry. Okay, an example of the inference engine. If we look here, we have three rules here. Rule number one, we have if y is true and d is true, then z is true. Okay? When we when the sorry the fact in a database y is same as d, then z will be true, and this z actually is the one that the new fact being produced by firing the rule, firing rule number one. And then we have rule number two: if x is true, b is true, e is true, then y also is true. If you look this on the arrow diagram, x is true, b is true, e is true, then it will produce y. Y also, it depends on the situation. Either y is available or the new fact that we add in the database. And rule number 3 also we have A is true and then X is true. A also might be available on the database where X is the one not available in the beginning but will be accumulated in the database after the rule number 3 being fired while A is true. Okay, so now we want to compare, have some definition of what we mean by forward chaining and backward chaining. Forward chaining is considered as a data-driven reasoning. The reasoning starts from the known data and proceed forward with that data. Each time only the topmost rule is executed. It is based on the arrangement of the rules. So if you want to make certain rules to become more priority, then you have to put it in the beginning of the knowledge base. So when it fired the rule, add a new fact into a database. And any rule can be executed only once. Okay? Once you, as per system, only execute one time any rules. The match fire cycle stop when no further rules can be fired. The inference engine will be stopped to proceed search for a rule when there is no rule can be fired. So this is the basic diagram of the forward chain. Okay, here we have a block diagram where this is a database. This is a knowledge base. Knowledge base is the rules. Okay, if we look here, this is how we arrange the rules. In the beginning of the system, the database only have A until E, A, B, C, D, E. Okay. So based on the fact that being available on the database, the first rule cannot be executed, cannot be fired. The second rule also didn't have a value of X. The first rule is value of Y. And then the third rule, okay, it can fire since A is available uh, in in the database. And once A is fired, database will be add by X a new fact inside the database. And then for the next cycle, in the same cycle, where C also available in the database, so C will generate after rule number 4 is executed, where it is C as a fact, then it will generate L. L is add to the database. And then L and M cannot be uh, cannot be executed since even though L we have, but we don't have M. Okay, and then for the next cycle, start from the beginning back. The first rule Y and D also cannot be fired in the cycle. The second one still X is already available, then X being used, and B and E is already available. So Y will be shared in the second rule is Y Y will be added as a fact to the database. And then A is already being executed, C also already being executed. The last rule L and M is where L is available, the fact M is not yet be available, so it will not be fired. So in the third cycle, since we have previously additional fact Y inside the database, then the first rule will be executed and produce Z, while the rest of it is uh, don't need to be executed. And L and M also cannot be executed since the database is not available. Okay, where forward chaining is a technique for gathering information. If you look, you didn't care of what is the result at the end. If the system can execute, all the rule will be executed. However, in a forward chaining, many rules may be executed that have nothing to do with the established goal. Sometimes when you set the goal, you identify the goal, but some of the rules, okay, so in forward chaining, there might be many rules that you execute, but it have nothing to do with the established goal. So therefore, if I were to infer only one particular fact, then the forward chaining inference technique would not be efficient. Unless if you are, if you can, I mean, if you want to gain knowledge of not particular fact, then you need a reasoning, you need explanation, then it is good to use the forward chaining. The other technique is what we call backward chaining. So a backward chaining is actually a goal-driven reasoning, okay? Where in the backward chaining, an expert system has the goal. Okay, in the beginning of running the expert system, we set a goal, a hypothetical solution, and the inference engine attempt to find the evidence to prove it. Of course, normally first you cannot find in the beginning. Okay? You directly get the goal. First, the knowledge base is searched to find the rules that might have the desired solution. Such rule must have the goal in their then action parts. Okay? The rules, action part, action, they must have a okay, if such a rule is found and it's if condition part match the data, the fact, the database, then the rule is fired and the goal is proved. But this is a rare case where you don't fire one rule and suddenly you get the solution right away. It does the inference engine put aside the rule it is working with? If let's say it cannot find the goal, why it goes all the rules. So what it do, it will put aside the rule it is working, where the rule is seen to be stacked, means that it didn't have the goal. And set up a new goal where it's called a sub goal to prove that if the part of part of this rule. Then the knowledge base is searched again for rules that can prove the sub goal. Then we try to find the other rules which can uh, get a data, produce data which is in the sub goal that we identified before this. The inference engine repeats the process of stacking the rules until no rules are found in the knowledge base to prove the current sub-goal. When we look at the examples, if we look at the examples, okay, our objective, our our goal is to get the z. Okay, we want to get z. Since in the backward channel it goes, okay, we find already z is in the first rule. But suddenly there was no data of y in order to fire z and to fire the first rule to get z. So it will set y as a sub rule. Okay, and then we carry on with the next rule. Okay, when it goes to the next rule, we find out, okay, sorry, in the, it will go through all first, and we find that Z is available here, but the first rule cannot be executed since you don't have the Y. So after you go through, it will set another goal where the goal says if the first rule is executed, then Z will be achieved, will be reached. So what you do, it will set Y as a sub goal. Y as a sub goal. So Y is a sub goal, it will check which rules that can produce Y. So if you look from here, the second rule can produce Y, but the second rules in the if part you don't have X. In the database, actually we don't have X. So it will set back X as a subgroup. So the next rule which produce X and also A is available at the database. So AX will be execute first and it will produce X. And then the second rule, since X is already available, the second rule can be executed where Y will be available at the database. Once Y is available, then the first rule can be executed and Z will be present at the database. Then you come into conclusion. Then you got the target. How do we choose between forward and backward chaining? Okay. There are advantage and disadvantage, and it apply to the certain application that you are going to use the expert system that you develop. Okay, if an expert system needs to gather some information and then tries to infer from it whatever can be inferred, then you need to choose the forward chaining inference engine. Okay, you need first the information, then you use a forward chaining. However, if your expert begins with a hypothetical solution and then attempt to find fact to prove it, then you need to use the inference engine. You have a goal before you start it, you need to have a goal, and then rather than you go through all the route, then you use the word chaining inference engine. Conflict resolution. Actually, we have discussed earlier. Okay, if we consider two simple rules for crossing a road. Okay, let us now add the third rule. This is the first, second, and third. Okay, you have the traffic light is red, action is still go. Actually, it is the same as the second rule, but we have conflict with at the then uh, then parts. Okay, where here we have two rules with the same if part. Okay, if the right is red, if the light, thus both of them can be set to fire when the action part is satisfied. This rule represents a conflict set. The influence engine must determine which rule to be fired, such a set. A method for choosing a rule to be fired when more than one rules can be fired in the given cycle is called a conflict resolution. We have two rules where impact is the same, impact is the same, then influence engine will select, will choose a rule. I'm sorry, the situation we call it as a conflict resolution. How we are going to solve it? So in forward chaining, both rules will be fired. Rule number two will be fired first as the topmost one, and as a result is then part is executed and linguistic object action obtains value stop. However, rule three is also fired because of the condition part of the rule mesh, the fact traffic light is red, which is still in the database. So as a consequences, object action takes new value. Rule number three is the last one that been fired. Then condition of rule number three uh, will be select, will be choose. So method to use conflict resolution, how you are going to uh, uh, if you are going to use a conflict resolution, how do you want to arrange your system rule? Okay, fire the rule with the highest priority. Okay, if you place the wrong, then fire. In simple application, the priority can be established by placing a rule in the appropriate order is also equal in sequence. So the first rule will be executed first. And usually this strategy will work well when a system is around 100 rules. 100 rules. You have 100 rules, then this is the method where you need to identify who which has the highest. Higher the most specific rule. And this method is also known as a longest matching strategy, where it based on the assumption that a specific rule possesses more information than a general rule. If you have a rule which are so specific, means that the knowledge behind the rule is higher compared to the others. If higher rule that rules uses the data most recently entered in the database. You know, each time when you execute the rule, there might be a rule which will add a fact to a database, will add a data to a database. So based on if you have a conflict resolution, based on the rule which are going to use a most recent fact will be fired. Meta knowledge can be simplified as a knowledge about knowledge. Knowledge is knowledge about the use and control of domain knowledge in the expert system. In rule-based expert system, meta knowledge is represented as meta rule. Meta rule determines a strategy for the use of task-specific rules in the expert system. So meta rule one, rules supplied by expert have higher priority than rules supplied by novice. You have to identify which one rule that being extract from the expert and which rule that being extract by the novice. Okay, and meta rule two rules governing the result of human lives have higher priority than result concerned with clearing overload on the power system. So actually anything that the involved with the human lives, it should be the highest priority compared to others. Okay, now we look at the advantages of rule-based expert system, where the rule-based natural knowledge is representation, and expert usually explain the powers of the procedure with such expression. In such situation, I do and so. This expression can be quite naturally as if and then production rules. It is a natural knowledge-based representation by the rule-based system. Uniform structure, since you only have if then structure, so it is a uniform, and each of them are actually independent within each other. The syntax of the production rules and well documented. Okay, and the next one is the separation of knowledge from its processing. As we discussed before this as well, the structure of the rule-based system provide an effective separation of the knowledge base from the inference engine, also a database also, where this make it possible to develop different applications using the same expert system shell. Then dealing with incomplete and uncertain knowledge, another advantage of the expert system, where most of the rule-based expert systems are capable of representing and reasoning with the complete, incomplete, and uncertain knowledge. Disadvantage of the relationship between rules. You don't have any idea what rule number one and number two are related. Number two and number three are related. Although the individual production rules are relatively simple, documented, their logical interaction within the set of rules is considered as object that uh, blur, that someone is blur, or you don't cannot see through, for example. A rule-based system make it difficult to observe how individual rules serve the overall system. In, in, ineffective strategy, search strategy, the inference agent apply an exhaustive search through all the production rules during during each cycle, where expert system with a large set of rules, is over 100 rules, can be shown and thus suggested as a system with a large set of rules where you have more than 100 rules, which considered as low and thus large rule-based system can be unsuitable for a real-time application. In most of the expert system developers are not intend to serve to a real-time application. It's not suitable. It's not suitable. Even though we can have external programs connected to the external system, but still we consider it slow to compare it if it runs for a real-time application. Okay, and the last one is advantage of rule-based inability to learn, where in general rule-based systems do not have an ability to learn from their experience. It cannot learn by itself. Unlike a human expert who knows when to break the rules, an expert system cannot automatically modify its knowledge base or adjust existing rules or add a new one. Yet the knowledge base engineer is still responsible for revising and maintaining the system. Still, we need a human to interface in order to update the knowledge base of the expert system. Okay, for now, I complete the expert system lecture. Later on, we are going to continue with the next uncertainty, certainty, probability. Okay, see you next. Assalamualaikum and good day.